Sean is a key architect within Arup Associates, having joined Arup in 1997. He's been, nearly 20 years now, so it's a long time. He has worked on various projects nationally and internationally, and a lot of the projects he worked on as well is in the Middle East. So he was a key architect for the CASC, which I think stands for King Abdulaziz Sports City, or Abdullah Sports City Mosque, Coventry University Engineering and Computing Building, and a major data center in the Middle East. He's also the project architect for Drak White Lotus School in Ladakh, which I think he will be talking about today and presenting. He won various international awards, and his experience goes between education, encompasses school and university work. His school work relies upon solar energy to passively heating of the building, so he very much takes the principles of sustainable building design within the approach of all his projects. I'm glad to welcome Sean with us today. Thank you very much for coming.
Thank you very much. So this story really begins with Arup, who started the practice initially as an engineering practice, and he actually studied philosophy before studying engineering, and this maybe is why he really questioned the basis on which engineering was practiced in those times, and worked with some of the very first modernists, including Beckett in the UK. And his thinking was really that the roles of architect and engineer shouldn't be split in the ways that they were at the time, but actually even more than that, he also wanted to look holistically at quantity surveying, construction, procurement, all of these things together, and that we shouldn't be thinking in relation to silos, but we should be thinking in a holistic way. So his concept was of total architecture. Implies that all relevant design decisions have been considered together and have been integrated into a whole by a well-organised team. This is an ideal which is well worth striving for, but artistic wholeness or excellence depends on it. So out of this idea, not because there was an inherent wish to expand practice, but because in order to create greater wholeness and offer something of greater quality to clients, that the various different disciplines were developed within Arup, and Arup Associates was developed as a multidisciplinary practice. So that's a kind of quick synopsis. We're about 52 years old now, and we have projects all over the world across various different typologies. And one of the other things that we were quite pioneering in was in relation to sustainability. It wasn't really called sustainability as such back in the 60s and 70s, but it was the buzzwords were about energy conservation, for instance. And this building here, the Snake Maltings, is a concert hall, and designed by Philip Dowson with Arup Associates, and there, this was quite a heroic building in that it was very much based on a local typology. So it was actually reworking an existing building, and rather than looking at it in a very ideologically driven modernist way, he wanted to create something which was of its place. So that's another running theme is architecture in relation to place and reinforcing identity. Many industrial buildings that we produced historically and office buildings. This building, 1 Finsbury Avenue near Liverpool Street, is listed, and we're currently refurbishing it and actually reconfiguring the interior entirely. So first project I was going to talk about was the data center in Qatar, we created the world's first LEED platinum data center in Frankfurt. And this is following on that work. This is the first LEED platinum data center in the Middle East. By making savings in terms of energy with data centers, you're making a huge saving, which is of actual international significance. So if all of the data centers in the world had the same energy use as this one and the one in Frankfurt, we'd be reducing the carbon emissions of the world by 1%. But it's not purely only about the careful design of the services, it's also about people. So this, for instance, is the entrance way into the building, which has an office component, and this creates this shading device for the cars, and also creating this sort of indoor-outdoor experience. And the shading structure takes its form inspired by nomadic tents. The aluminium that you see running around the entire facade has a very high, it's 80% recycled content. So it's all about actually specifying very specific things and looking at a whole range of components that come together to create a sustainable architecture. And that's not simply about the end product, it's about how the building works in use as well. These are the air extract funnels. Education, so this is the Believe in Better building for Sky, which is created in a record amount of time, and it's using a timber cassette system using Glulam timber, which has very high embodied carbon, so it reduces the carbon footprint essentially. So it locks the carbon into the building. And you have this staircase which links all of the main public spaces together, and is really an extension of the public square, creating a central campus for Sky. So that's some views inside. Coventry, sorry. Coventry University Engineering and Computing Building. I don't know if any of you know Coventry, but it's being quite dislocated by the introduction of the ring road. And what we were interested in doing was creating a more historic kind of city footprint, creating a new public square off which the entrance is formed, and modelling the building in relation to its local buildings. And what we had as an interesting brief from the university was that they were interested in a new pedagogy linking the students together so that they actually learn from each other as much as from the teachers. So rather than sort of having several ranks of pupils facing one direction, as we have here, the classrooms are related in sort of clusters, so you can have nodes of learning. But there's also this interactive space, which is very popular, where it's a circulation space, but there are areas of it where group learning and individual learning can take place, and that's open 24 hours. That's a beautiful model. We work a lot of using physical models in-house to trial ideas, and the facades used this hexagon motif, which is idiomatic of the idea of the singular individual within the whole. and we have a timber mullion system. It's naturally ventilated in the main and achieved a 3M excellent rating. So this is a view of this interactive space, which is a very lively space. So the social aspect of sustainability is something we're very interested in. The hoods that you see over the glazing, they moderate the solar gain. There's some more views of that space. You can see there's this internal lining. It's perforated with acoustic material behind it. This is something completely different. In a school in Ladakh, which is a free school from primary through to secondary, that I've been working on for the last 20 years. And we've incrementally built it as the children grow. The schools use local materials, so the stone, the granite comes from the site itself. And it also uses an earth roof, which is locally designed. But it's a seismic area, so we have a timber frame, which also allows for a great flexibility in terms of how the spaces are configured. And the buildings are all passively heated, so the daytime buildings have glazing to the south, but the residential buildings, half of the school population is about 700, 800, half of that is residential pupils. And they have trom walls in their residential buildings, which dissipates the heat during the night as well as the daytime. So there's some models and some of the drawings that we take out to site, and we've been sending out residential engineers and architects. The figure that you see there, of which the plan is based, is using the figure of a mandala, a 9-grid square, and then we have a central courtyard here, and then this is the residential spine, off which the residences are located in the dining hall. So all the buildings are entered off courtyard spaces with shading through trees. And we also have PV arrays that provide sustainable power. The courtyards themselves are articulated in order to create a sense of a spatial sense, which is determined by the children themselves. So it's less forbidding, because you're looking at actually a great expanse of desert with the mountains. So we're trying to reduce the scale to something which is much more child friendly. And that's the opening back in 2001. And children. This is to yet to come. This is the library that we're designing in the centre of the school. Moving to Saudi. So this is designed for a mosque as part of the CAST complex, and this is creating a forecourt to the sports centre itself. But it also allows for prayer to take place outside as well as within the mosque itself. And what we were interested in here was to reinterpret local tradition, both in terms of form and materiality. So whilst the roof has some kind of relationship to mosque domes, it is clearly of today, it's contemporary. And it's formed by a series of cylindrical forms that come together. And we have a tiled surface to the roof, and precast concrete elements creating this arcade. And you can also see the minaret there. And there we are. There's a, oops, sorry, it keeps on moving on. Maybe I'll try the mouse. So one of the things we were interested in there is pattern and how one could modulate patterns using Islamic prototype, but in a contemporary way. So using computers at our disposal now, which can allow for quite a degree of variance. So this screen here varies, the openings vary in size over the height. Brilliant. Brilliant. This is fine. Thank you. So back to the UK. So this is in Dalston in London. Very dense housing scheme, which created a major square in London, and it's one of the hubs around a new railway station. This was again a BREEAM excellent scheme, and it created these series of terraces, but there are also winter gardens for a lot of the units, which allow the children of those families to play safely at high level. And this has CCHP plant. So that's a work in progress, you can see, but there's a new square there, and there's a McCaslin scheme on the other side, and this also had a library at the base. So a mixed use scheme with retail along here and some sort of work units at the mezzanine level. There's some details there with this double height winter garden, naturally ventilated housing. Science and industry. This is up in Wolverhampton for Jaguar Land Rover. Tata were the client here, and what we were trying to do here was some quite simple things really, which was all about creating a much greater sense of dignity in the workplace and enjoyment through natural light, which seems obvious, but wasn't something that was common within their machine rooms previously. And the other thing which was key was the office component, having views between the actual factory floor and the office, so breaking down those visual barriers. So that's a view inside the machine room, which is creating the engines, and some of the Revit call-outs. So with the north lights, and this is the office component, which can be naturally ventilated. It's one of the finished shots, and there we are. Sports. So Singapore Sports Hub. This is a 55,000 seat stadium, which is can be used for a number of different sports. It's a sports venue, not only sports, also for concerts, and it is the largest free-spanning dome structure in the world, 310 meters. And the key thing in the design here was to look at the design of these elements, the opening roof, And by coming up with a design for the pulley system, we were able to keep that load down greatly. So as a consequence of that, the load of the whole dome is kept to a minimum, and the steelwork used is a fraction of that used, for instance, for the bird's nest. Another key idea here was to do with cooling. So rather than cooling the entire volume, what we provide is cooling locally to the seats of the spectators and also for the pitch. And by doing that, and that's working closely with the regulatory system in Singapore and actually kind of questioning that, it's much more efficient and much more environmentally sound. We also have this zone externally, which is just shaded, which creates a wonderful route around the stadium, because there are very few promenades within Singapore that you can take, which are really pedestrian friendly like this. So that's gives you a sense of that space, and the opening of the roof also allows the sports centre itself to connect with the city, so you can actually hear the roar of the crowd when you're in across the water, and similarly the views back to the city are a fantastic backdrop. So there we are in its open mode. And what we're also interested in is again to do with scale. So when this structure meets the ground, this design of this concrete base was looked at and refined to a great degree, and right down to obviously the procurement stage, so that there is a certain delicacy to it, given its massive scale, so that it relates to the human scale. This is a very small sort of mini stadium which we did for Doha to help them win the Football World Cup. And this is the first ever carbon neutral stadium in the world. Although it's a tiny one, but it created basically the precedent on which all the stadiums are being built in Doha currently. And you can see the shading structure for the roof, which is retractable. And here you can see these solar collectors. So these solar collectors, they basically transfer the solar energy into cooling. So when the roof is closed, you cool space entirely through the sun's energy, and then the PVs provide energy for power. Cast stadium, so back to Saudi again. So that's just an image of the structure, as you can see there. So we're once again we're looking at how we could create a shading structure which had a relationship to the history of Arabic art and architecture, creating this route around the stadium which allowed for a comfortable temperature, but actually outdoors. It's a naturally ventilated stadium. There's a picture of the interior. And that actually seats 60,000. This is one we're working on at the moment in Qatar, which is a tennis centre primarily. I mean, it has retractable seating, so it can be used for a venue for a number of different things. but that is relatively tight. It's 15,000 seat stadium, and again we have this lid that closes over the central oculus. And one of the key ideas here was to actually expose and celebrate the bowl. So you can clearly see the bowl of the stadium articulated in relation to the front of house venue entrance area, and it also creates this unique plaza here, which will be a public square. So this is meeting the local Tari equivalent of Briam. Sorry, I can't remember the name of it. So that's some details of the roof. And here, this is, sorry. So this is in nap vent mode. So this is with the roof open. And you can see the air is circulating through and out through the roof. And then when the roof closes, we bring in cooled air local to the seats, which is then extracted into the roof space, and there's a heat transfer system so that it's efficiently the energy is recycled. And that's a view of the interior. So onto commercial. So this is just received practical completion. Actually, this is the existing campus for Pinewood, and then there's a new series of studios. So this is where they basically film a lot of the blockbuster movies, such as 007 and so on. And this was actually quite a controversial planning proposal, given the fact it's in the green belt. And we achieved the planning commission by coming up with a scheme which had no loss of biodiversity. So the existing hedgerows and these green areas were all maintained, but actually enhanced with greater mix of planting. But also the majority of the roofs have biodiverse roofs on them, which is, I think, unique for a film studio. These are very large steel structures. And the other component which is key is obviously acoustics. So they are formed with, the base has precast panels, and then above that there's a timber cassette system which is perforated internally, so that basically the mineral wool offers its performance in an acoustic absorption, both in the wall plane and in the roof socket. So that's a key requirement, but it is how we bring those things together in a very efficient way, so that a number of things are doing multiple jobs at the same time. This is a naturally ventilated office building for Arup itself. It's our office in the Midlands, and here we're creating a series of pavilions which are 24 metres in depth, so they're quite deep for cross ventilation. And the way that that's enabled to work is that there's actually a double height zone here with a series of voids, and air is extracted through these flues. And again, we were sort of interested in the local vernacular of farm buildings, and it is actually known as the chicken shed locally, but that wasn't us naming it that. So we have a combination of BMS controlled opening vents within the facade and at roof level, and these also work as smoke vents. But there are also occupant control is very key. So there were sash windows as well. So the design is also based around economy of means. So the steelwork is exposed, the concrete soffits are exposed, and their cool is key to the design. Minimal materials used, but that obviously requires quite a lot of thought and coordination. Cedar cladding. That's a view across from the local lake. And we also designed this light fitting here, which has acoustic absorption built into the wings. And this was actually built over two phases. This is a model of it it's in the V&A Museum. Transport. So this one of the things that we're very interested in is the feature of transportation moving beyond the reliance on the car. This is the Vauxhall Cross interchange, which largely is about buses coming and going. And it has these tuning fork roofs which announce the building, but they also provide an armature for PVs. So these PVs actually provide all the power that's associated with the lighting of the scheme. And it's based around a series of ribbons, stainless steel ribbons that drop down and create seats. Unfortunately, it's threatened with demolition at the moment. There's another master plan which seems to be...
Sorry, so they're going to put down the whole building?
Yes, unless we get it listed, yeah. This is a series of underground stations in Denmark. And here, one of the key things is bringing daylight deep down into the concourse, which is partly a way of obviously reducing energy, but also it helps to orientate oneself. And going beyond that simple science, we also were interested in varying the materiality, which gives a sense of identity to each station and has a relationship at street level. So it basically picks up on the architecture of that particular zone within Copenhagen, so that there's a dialogue. Blackfriars Pier. So here we've got the North Bank here, and there's this armature here that brings you across to this kind of pontoon where the boats land. And I mean, I don't know how many of you have travelled up and down the Thames, but there's not really that much of architectural significance actually on the Thames itself at the moment. So we're trying to really improve that whole situation and have something of refinement. So this roof creates a really beautiful sail, integrated lighting, and with a glazed area here as a waiting area. Celebrating